So the title of my talk, the AQUA ecosystem, it was a quite quick shot. And I would like to give you some ideas about how to train, what to train, and of course how we do this in the AQUA movement, I would even say now. This is of course the commercial part of it, but it ought to be that way. Do you know this? Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. Who knows this? Probably in here many. Is this important? Is this self-explanatory? Probably not. It involves organization, that is management. It involves design, which is a different department. If you don't stick to that, you are in trouble. That's what it says here. You're constrained. You can just produce things that have the same communication structure as your organization has. Now that's not an easy observation. So the reaction to that, I mean you've spotted it. That's Conway's law, and it's quite old, almost as old as I am. I think the ideas are older. Because it's kind of wisdom, kind of truth. Everyone working in an organization, doing complex things with complex organization structure has felt this, I'm sure. And there was one guy who wrote it down. So reactions to that. And I took this Conway's law just as an example. So there are more of these laws. Reactions, when you tell this to someone. So one reaction could be, I don't believe. I mean, that's so far apart, that's organization. On the other hand, it's design, it's engineering. And that should constrain me, that's so far apart. So, I don't believe. Okay, that's why you fail. So I know some people in here expect a Yoda code from me. But when you manage finally to persuade someone, and then I'm talking about this relation, trainer, maybe experienced trainer, and unexperienced apprentice. So a very asymmetric relation. And I would like you to keep that in mind, this picture, this asymmetric relation. Because we need it in the end. That's what I heard recently. Hey, why don't we learn that at university? I was puzzled, because it was a university course. Actually, it was an AQUA course with a material that we developed during the AQUA project. And I gave this at university for students. And so finally, they somehow felt, hey, that's something. They experienced it. And they said, why don't we learn that at university? But then, of course, well, you do now, here. But is it? Apparently it's not so easy. To which department do you go? To which lecture do you go to learn this? So, the management department? The engineering department? So it's very separated. But, what the student actually, the observation is that students want to do the realistic stuff. At best, the real stuff. But that's some risk, I don't know. Students want to explore and solve, finally. That gives them, of course, a good feeling. And by students I mean everyone who learns. That's have this very general role to that. And students want to be exposed to complexity, to real world complexity. So that's somehow not intuitive for designing the course, isn't it? Or is it intuitive? What do you think? I mean, the situation is as it's out there. There is this complexity. Of course, when designing a course, you can abstract and abstract and abstract, and so that every problem becomes easy. But whom do we educate then? People that use and need this abstract wisdom and have no idea how to apply this in practice? We need to gap this. We need to bridge the gap. No? So we have to expose the student to complexity. And they like it, I tell you. So now I come to the content. Okay, there is a mistake on the slide. I want to talk about how and what to learn. I want to talk about evolving and growing in this context, and I want to talk about how and what to teach. Okay, so there is this cone of learning. That's the theory. You have seen it before, I guess. There is a small disclaimer on top in the gray box. It has a very controversial history. The author himself warns about misconceptions, so take it with a grain of salt. Especially the numbers on the left side are rubbish. Okay. But there is something in. So if you read something, you remember definitely less than if you do the real thing. So this is the other extreme. Do the real thing. You remember more or most. Of course, there is a stack to it. And originally, this Edgar Dale was thinking about audiovisual media in training. So that's taken from, that's the history. But of course, what's in there? There is a passive part about receiving, of whatever kind. And there is an active part about doing. Okay? So, there must be something, because there are many observations, many papers, many people wrote papers and tried to do this very scientifically, yeah, there are many discussions about that. Still, there is another thing here. An even older paper suggests that we remember less if we only think about the abstract things. So if we abstract something to death, and we know nothing, and we learn nothing. If we do the concrete, we remember more. So this is a nice coincidence. It's a different source, but it's a nice coincidence. So when we want to do then effective training, then we should probably stick here. We want to remember more to be effective. We want to do the real thing. In order to achieve that, we want to be active, and we want to have the concrete. So that's the same thing as the student actually told us. Why don't we learn that at university? Don't abstract this to death. Give me the real stuff. I can take it. So that's theory. Of course, we could have had it easier. We could have just looked up Confucius, and he said, I hear and I forget, I see and I remember, I do and I understand. Too easy. And very old wisdom. Okay, so there seems to be some coincidence in that. Okay, what do we in AQUA? So now comes the, not yet the commercial. We take we try to take realistic system engineering scenarios. We also say, okay, give me your scenario. If you have one, we can work together on that and learn on that scenario. That's one of these ideas. Of course, that's not always so easy. We also have prepared examples, and you might recognize this picture from several presentations yesterday and even today. So, we have taken this electronic steering column look as one of these scenarios. If you don't find some interesting scenario, we take that. So we give some guidance to get a realistic scenario. And then we try to work on it and learn. Recently, the e-motor drive is probably becoming another elaborated scenario that we can take for education purposes. That's a new development. What do we do then? Okay, assignments. We do. So we, of course, try to understand requirements, come from fuzzy customer ideas to real measurable requirements. We do CTQ flowdown. I mean, we don't do it like a real project in industry, but we urge the students to try it out, to play around, and to get the feeling, get the experience how this feels. We do, of course, for the safety guys now, item definition. We do the HARA to have some idea about how dangerous the system is. We do requirements and traceability. We try to devise architecture on several levels, on system level, on hardware, on software level. I mean, that's a lot of stuff, of course, and can be tailored. But still, these are at least some of the assignments. We continue with FSC and TSC. If we go more to the safety part, of course we almost always need this FMEA as a tool. We want the students to understand how this works and try it out. Many FMEAs are out there, many FMEAs on several levels, but I mean, if you have never heard about it, let's do it on design, try it out. And then we will learn about our system. Hey, if this ignition switch goes wrong, people are killed, so we have to do something about it. Okay, we develop, we design a new safety mechanism, and of course someone has to implement it. We need a process to be sure that in the end we get what we want. We let the students play around with design of experiments. I mean, of course, that can be huge, but playing around, feeling it, what's behind. Of course, verification and test is something you must not skip anyway. And again, there is this traceability stuff in there. We also try to watch this process. And so you must imagine we do this during the course over several days. And so we develop it on this scenario, it gets more and more detailed. And we watch ourselves what we do and how well we proceed. How many requirements do we have? How many requirements do we have traceable to some software requirements or design? So we watch it and we try to to observe and collect metrics, to think about what we are doing. There is also a unit in there about reliability. So there's a full toolbox of assignments. That's not a theory, that's an assignment. Let's do it. So this is then the full house of AQUA as it currently is, because it's of course also subject to evolution. And what you see here, the structure of the house, there are 4 perspectives currently. And these 4 perspectives are automotive SPIs to cover the development process. This is the functional safety perspective, ISO 26262. And these are methods from Six Sigma, as we need them during design. That's the current status. And there is the integration perspective. And there is this fusion magic occurs, where we bind all the ideas together. And this is, we discovered that this is done mainly in the exercises, because there are so many disciplines, and you have to try it out. You have to try out that, okay, if I want to do something, if I want to do a design, I should know about the requirements, and I should know about what the customer wishes and how I measure it, and I should know maybe about how dangerous the system could be. And there are many links of thought through the system. It's a complex situation. And the observation is, if you expose the trainees to that situation, and let them try out, and let them feel, oh, I don't have that, I cannot continue, so I have to do it earlier, something from another dimension, from another perspective, then that's also learning. Then we come close to this complex law, which is, of course, the next abstraction, because you cannot have different departments there not working together. We don't know which structure we will achieve. Okay, now it's just a listing of elements we have in there. Of course, there is an introduction part. I would say that the main part is, of course, the product life cycle and, the product development, starting with life cycle and crucial phases in that life cycle. There is quality and safety management, capability stuff and hazard and risk, which all have their meaning in the different pillars. Okay, capability. Of course, in automotive SPIs, capabilities, yeah? That's one of the key points. And also capability of a functionally safe product is that it's safe enough. It's also kind of capability. And you can continue on this thinking. And there is a measurement unit about measurements in general and in particular about reliability. So that's the current status of this skill set. And we try to train this in just a few days. You can imagine that these guys are not experts, but they should know about the complexity when this is done in reality and how to proceed further. Okay, so I think I've explained this anyway, so that's what's in one of these elements. Maybe one point here. These are very small elements, and these small chunks of theory, more or less their theory, they are very helpful. You can pull them out. If you are in some discussions, you can pull out one slide or pull out the unit and show. So that's very useful if you want to show something. And if discussion is exploring a domain. But of course, it has also a drawback. Sometimes it's too modular. You have to have a way through it. And then very often you need a guide. And that's one of the follow-on projects where we do that. Okay, that's the link to more intensive courses that are anyway in the market. So in the AQUA we want to do the fusion of concepts and the overview. And of course there are specialized courses anyway to do the stuff in more depth. As I said, AQUA alone doesn't make you an expert. Okay, so I was not sure whether to show this. So these three animals here, they're quite different, yes, I know. I had a colleague in my former company who always used this. And they always, when discussing something with someone, he said, hey, come on, elevate from your ant view. At least take on the ant-eater view. Okay? So the question is, how big is their world? And the question is wrong, because they have different focus, and the worlds are different in size. Because the ant cannot overlook a lot compared to the ant-eater, and even compared to an eagle. Still, it's one and the same world. What does this tell us? Maybe we should always be aware of maybe three abstractions. A higher viewpoint is very often related to a higher abstraction. So what we should be able in the end is to link these together. Okay, if you do, let's say, if you do some, let's be the ant-eater. So, okay, it's somehow it has an elevation of maybe 1 meter. It can look around. And so maybe that corresponds to the role of an architect, a project manager. When you do such kind of stuff, it's very helpful to understand what the ants are doing, the experts. It's also interesting what the strategy is saying. Okay? So in addition to all this domain linking together, you always need viewpoints. 3 viewpoints is not a bad idea. But that's the concept of one of my friends. But I find it very good. So it helped a lot. When we do training, we want to, as a student now, maybe as a student, just, no, come to that later. We want to experience real-world complexity, of course, without drowning in detail. So we don't want to be the ant when learning. So it's enough to have 2 abstraction levels. Do something and reflect on it, more or less in an integrated way. We work on realistic problems, but we want to work on it in an open solution space. We don't want to be constrained by some prepared example where everything is without variation, fixed without variation. So we want to work in an open scenario. What does it mean for a trainer? He does not know. It's a bit of uncertainty. Okay, so that's the challenge. But that's what the students, of course, need. Because some of the students in industry, they have real problems, real world problems, and they want to solve their problem. So if you want to do the real thing with them, you have to deal with their problem. There is no way out. Okay, so that's, I put here the ant-eater, because working on problems involves also the detail. So we need to be the ant here, we need to be the expert, but we also need to be the ant-eater. Okay, small chunks of theory to allow an exploration path on demand. So it has some dangers, but it's good to have. It works. So theory is very often the ant perspective. But then we should not forget about the anteater. So always have at least 2 levels of abstraction in your mind. That helps when learning and understanding the links to other people, to other domains, beyond your anthill. What you want to have, of course, is a guide to ask. That's something crucial. That's we learned on the hard way during the first AQUA courses. So, but this guide to ask has then at least all 3 perspectives. So that's the challenging part. Okay, now the ecosystem. I took just a few things out of the definition of a business ecosystem. It's a community-supported foundation of interacting organizations and individuals, so many agents. It produces value, okay? And it has stakeholders, different roles in that ecosystem. But over time, they co-evolve. So the ecosystem lives. There is something stable in it. It's a shared vision and mutual support. So that keeps this thing together. It's not completely stable, but we hope it's stable. And for some time it works out. So hopefully long. AQUA started as a sector skills alliance for automotive. So that sector skills alliance actually for a certain sector. That was a new idea by the European Union to involve the sector, the domain, because they just could give very abstract recommendations. And the idea was, of course, to involve the sector. And we got this project for automotive, and that was actually the core of AQUA, where we also wanted to build an alliance to have this curriculum. Okay, I've shown before, but of course that's not fixed forever, that also lives. We wanted to be strictly industry aligned, so that should be an offer to industry. And of course we want to roll it out, at least on European scale. That was part of the European project. And of course we dream about rolling out it on worldwide. This is something we had, that was the original idea of what comes in. 3 pillars that have to be closely linked together in the minds of the people. And of course we need a certification for industry acceptance, and this is of course where EasyQA came in. What has been said about EasyQA this morning already. And we wanted to go to the automotive clusters as a multiplier. And of course the university, but okay, we have the university partners anyway. So the original network was TU Graz, IACN, Symbol, who runs the first 2 have been presented anyway this morning. Symbol runs the Lean Six Sigma Academy. EuroasiaSPI is an association of research laboratories. And EasyQA is a certification body. And 2 automotive clusters. That was were the original partners of AQUA. But of course you can see these emerged from somewhere. And this somewhere can be seen as EuroSPI, Socrates, these communities. came out of the blue, of course. Okay, so that was the original part, but now we are growing. So there is another project where the universities say, okay, not just TU Graz is saying, because we were part of this project, and Grenoble Institute of Technology is saying that's nice. There are now more partners, there are university partners. So suddenly we have TU Ostrava as leader of this new Automotive Quality Universities project. A follow-on project, of course. But now we are going to universities. We have the University of Applied Sciences in Graz. No student in Graz dealing with cars. Every student has to hear about AQUA. That's the intention, of course. There is no way out in Graz. So there is University of Maribor, electrical engineering and computer science, 2 departments even. They want to incorporate this AQUA into their studies. EuroasiaSPI is again on board, and in turn the Grenoble Institute INP, oh, I'm not French, sorry. You will have to ask Andreas. But then the second thing what's behind that EuroasiaSPI is also Hochschule Düsseldorf, which is not formally a partner of this project, but it's part of this, put it bold, movement. And of course there is this online campus for industry where we can do online trainings. What we essentially want to do is to bridge a knowledge gap. We discovered before that the automotive industry has needs, but the university teaches sometimes a bit old-fashioned needs. At least old-fashioned structure. So that's the thing we want to solve in here. What we do at TU Graz is we have this as a normal course for students. And that's new since the summer. We are having a formal university course offered to the industry, from TU Graz to the industry. So we have again these 2 ways to go. The interesting thing is that it's, at least at TU Graz, the first bridge between the ECTS world and the AQUA world. So that's the Bologna credit system for university, which is well accepted, and the not yet so accepted industry credit system. Okay. So I just want to give the key message here. Each organization in this project is finding its own learning path and its own distribution of the AQUA contents to lectures. So each university does it differently. That's an interesting observation. But still, it's the same spirit. There is another project, Automotive Engineer, which essentially wants to develop a web stream for people, for first graduates. So another project with slightly different partners. Again, just showing the alliance is growing. Okay? So the current state is then, of course, we have these automotive quality universities. We have Automotive Engineer as follow-up project to AQUA. We, of course, refer to the Six Sigma educations out there. In particular, also the ECQA-powered Lean Six Sigma Academy. There is, of course, the SAFER, the Safety Manager course, which I really like to do. There is Automotive Spice courses, which we also refer to. So these are then the official courses where you can study the full scope of these topics. Of course, I have to mention here the Integrated Design Engineer, which is the spirit actually to integrate Of course, there the integration is along the life cycle, but also about between departments and between disciplines. New ideas. This is somehow imminent. You feel it. You have heard it. It's natural to include that. Cybersecurity is an additional pillar to this stuff. Or maybe MOOCs. Make the stuff public. It's ideas, it's just to, the ecosystem. SPI manager, that has been announced this morning. It will be somehow restructured, renewed. SPI as facilitator. That also fits to that picture. So we are growing. Okay, and more. So I guess I will skip this, what the European policies say. Essentially they say involve the industry and we need STEM skills. Okay, science, technology, engineering, mathematics. Do we really? Yeah, of course we need. But we need them networked in your brain. So again, we are back to the real thing. Okay. Few words about trainers. So it's challenging. You have seen it already. So you have to provoke real world and complexity dynamics in your training. Okay. Try to do that. So you have to, of course, you have to have all three perspectives to, as Yoda would put it, poking you with a stick. Of course, stay in contact with industry. That's a must. Otherwise, we don't know the real problems. It's always very easy to lose that contact. Beware of that. Again, on all levels. Know what you teach. Be prepared for questions, for really questions that you don't expect. If you make this in an open scenario setting, okay. Be prepared. All abstraction levels, all viewpoints. And be a guide and a coach in all situations. That's also tough. Takes our views. So, the question is this impossible? It's challenging, yes. Very challenging. What can we do about it? Do the real stuff yourself, of course. Try to do it at least. To feel what the real stuff is about. And always stay authentic. Again, we could have gone to Confucius. By three methods we may learn wisdom. First, by reflection, which is the noblest. Second, by imitation, which is the easiest. And third, by experience, which is the bitterest. And I'm afraid it's only the experience that remains. Okay, just one more slide to make this all recursive. By learning you will teach. By teaching you will learn. So, do you remember this scenario of the young apprentice and the experienced teacher from the beginning? It's more balanced than you think. Being a teacher is being a learner. And you can learn a lot from your students. So, always be humble. And now we can turn around and take the talk again from the viewpoint of a teacher as a learner. And then we can take the talk again on different levels of the abstract. Okay. Thank you.
if no one is asking, then I am asking.
Advocatus diaboli.
Huh?
I fear it. Advocatus diaboli. Yeah.
That's right. Yeah, if no one is saying anything, I'm advocatus diaboli. If you use Latin, I can use Latin. Yeah? There was a slide with the ant, eater, and the eagle, right?
Yes.
I was thinking that the ant eater is eating the ant, right? And the eagle eats the ant.
That was just a joke.
Okay, good.
But the ant, did you notice what the ant can do?
Yeah, what is
They
it?
can do quite some magic.
Yeah, this is and what I saw in the picture as well is that the ant was capable of doing much more than the ant should be capable of because of the size. Okay, good. So I was not sure if I saw this thing right, because that would mean that you see the experts or the engineers as those who can do much more, or the students effectively, than they believe, and it's the ant eater who should empower them. The only question in my head is then, why does the teacher eat the student? Because maybe I have to understand still one part of the picture.
No, that's just a joke.
Okay. Okay, now then I understand. Because the eats in sequence was a bit funny. Yeah? Okay.
Yeah.
Haven't been hungry enough.
That's very often, the observation in real situations that the ant eaters eats.
That's the only possible food of the teacher.
Well, the food for the teacher could be the thought of the student, but not the flesh of the student.
Yeah, that's a better way.
Well, there are people who believe that by eating your enemies or whoever, you can incorporate their abilities and their knowledge into you.
Yeah, so and maybe that was his advice for teaching students, but I hope not. Yeah.
Very close, because he's looking at me.
I did not think about this picture, I'm afraid. That was really just a joke.
I have to admit, I should have replicated maybe, but it at least provoked the thought. Yeah.
Didn't you take the AQUA course? Then you would know that you have to review it.
Yes. No, then there's a content question. When you presented this, I think it wasn't visible how we extend this network, because there were discussions that we involve more universities. How many ECTS we give? What's the framework of how many ECTS each different university is giving at the moment for that course? So I was missing that point. Can you say a few words to that?
Yeah, as I said, each university finds its own way to incorporate this AQUA stuff. It's not, as it's very modular, that's possible. There is, actually you're very bound by this ECTS schemata, how much you give in terms of ECTS. It depends actually on the workload. How much space do you have for teaching?
Yeah.
One university teach this, we do it in a 1 week block course. Another university incorporates it to something they have. So the approaches are different. And of course we have thought about a mapping to the ECTS world. The other thing is that the blocks that you have seen are just chunks of theory. And the big block, of course, is the scenario, working on the scenario. And this takes some time, so that's where many ECTS can go in. It's scalable. Working on this project is also scalable. You can do, you can just try it out, or you can elaborate more. If you elaborate more, be sure you learn more.
Yeah, but I think to talk about numbers, as far as I have seen, we had about between 2 or 5 CTS maximum. Yeah. But when I saw how we defined the AQUA course for the industry, from the technical university to the industry, there were more ECTS.
Yeah, almost double. Because we had this idea of doing more extensive case study, more content.
Yeah. So So I think what we should say is there's an offer to the other universities to share. Yeah? And just to give you a hint, I had some discussions with FH Kassel to also join. Yeah? And you should meet Maria. Where's Maria?
Yeah.
Okay. She is interested in also getting an agreement for Sophia University. And I think there's someone from Augsburg here, and you should contact him and at least show him what we have. Okay?
Okay,
Yes, we should get a growing number of universities.
Which is Kreiner in the session?
No?
No, okay, no.
Right, but I only told you with whom you have to drink coffee the next.
Yep.
Okay. Good? Okay. Thank you very much.